Biorefinery System Module 12 Lignocellulose Biorefinery Process Engineering Part 2 Segment 1 Steam Explosion and Pretreatment Equipment. With me, Yusuf from Bioengineering Study Program, School of Life Sciences and Technology, Institut Teknologi Bandung. In this module, we will discuss about unit process and equipment in lignocellulose biorefining that includes brief explanation on the steam explosion pre-treatment and equipment, carding fractionation equipment, solid-state fermentation and gas double dynamic solid-state fermentation bioreactor, and online determination and automatic control in the lignocellulose biorefinery process. The lignocellulose biorefinery process is a system integrating a series of unit operations, mainly including raw material pretreatment, fractionation, fermentation, hydrolysis, drying, and online determination and automatic control operation. Based on the main techniques and equipment, this module will briefly introduce the key unit processes in lignocellulose refinery engineering. The first attempts at steam explosion for the pre-treatment of lignocellulose began in the early 1980s. Raw materials were heated to 180 up to 235 degrees C by steam, and the pressure was maintained for a certain time. Under high temperature and pressure, the acetyl of the hemicellulose generates organic acids and then precipitates in the catalytic process of hemicellulose and lignin depolymerization. Hemicellulose is hydrolyzed into soluble polysaccharide, and the lignin is softened due to the breakage of the alpha-propylene ether bond and parts of the beta-propylene ether bond. As a physical and chemical method, the steam explosion pretreatment method enables the three main components of lignocellulose substances to be utilized respectively because it can effectively isolate the active fiber without the use of chemicals. Therefore, steam explosion pretreatment technology has the advantages of no environmental pollution and low energy consumption, which makes it one of the most widely used methods of lignocellulose pretreatment. Steam explosion adapts high temperature and high pressure steam to deal with the lignocellulose and component separation, and structural change of lignocellulose are realized through the process of instant decompression. Generally, raw materials are treated with high-pressure steam in a pressure-resistant reactor and then decompressed rapidly, forcing the material to be released into the atmosphere. However, it is recommended that the best pretreatment conditions for hemicellulose were 500 to 550 Pascal for 40 seconds. Since then, steam explosion technology has been widely used in the pretreatment of hardwood, softwood, and agricultural waste and other non-cellulose materials. Steam explosion pretreatment has several advantages. First, pretreatment conditions can be easily optimized to produce high yields of specific chemicals from a wide variety of plant lignocellulose. Second, hemicellulose, lignin, and cellulose can be separated during three different process units to produce water-soluble, alkali-soluble, and water and alkali-insoluble fractions, respectively. Third, theoretical enzymatic hydrolysis conversion yields of cellulose can be achieved. Fourth, the lignin component is still suitable for chemicals production even after steam pretreatment. Fifth, sugars generated from hemicellulose can be fully utilized and converted into liquid fuels. And sixth, the release of fermentation inhibitors can be considerably reduced under optimal pretreatment conditions. In addition, the cost of the steam explosion pretreatment process is low. These advantages make steam explosion one of the most widely used pretreatment technologies for lignocellulose biomass. In the steam explosion process, some chemical reagents are usually added as catalysts, such as sulfuric acid. These reagents can also be added before steam explosion to improve the hydrolysis rate of hemicellulose and reduce the inhibitors for enzymatic hydrolysis. The addition of this kind of reagent can increase the proportion of monosaccharides in the total hydrolysate and decomposition of the acid-soluble lignin. The removal of lignin and degradation of hemicellulose increase the pore size of cellulose, enhancing the hydrolysis efficiency of cellulose. However, the addition of chemical reagents causes environmental pollution, and the equipment requirements also increase. Currently, the most successful commercial application is the SBC process by Canada's Stick Company. This technology uses a continuous steam explosion process, and the heating time and temperature are strictly controlled. The cost of steam explosion pretreatment is low, and the enzymatic hydrolysis yields of steam-exploded lignous cellulose are improved remarkably. Currently, steam explosion devices have been successfully applied from a laboratory scale to an industrial scale as shown on the figure. Figure A shows a 5-liter laboratory steam explosion device, which mainly consists of a steam generator, a pressure holding tank, and a receiver. The operating pressure is 0 to 2.5 megapascal, and the temperature is 0 up to 250 degrees C. The feeding valve is manually controlled and can be connected with nitrogen bottles to achieve a mixed gas steam explosion. Figure B until Figure D shows the enlarged steam explosion devices covering 1 meter cube, 5 meter cube, and 50 meter cube respectively. For the next segment, we will discuss about cardium fractionation equipment. Until then, I am Yusuf from Institut Teknologi Bandung.